Okay, now moving on, let's look at the osmix parameter. So osmix is right here. This value sets how much oscillator 1 and oscillator 2 are mixed into the generator's output. If it's 0.5, then the output is equally comes from oscillator 1 and 2. If it's 1.0, then all of the output comes from oscillator 1, and if it's 0.0, all the output comes from oscillator 2. So I'm going to adjust this now, so that way we're only listening to oscillator 1 by setting it to 1 for every step. So again, you hold triangle and you push the analog pad up. So now it sounds the same because the offset was 1.0, so oscillator 1 and oscillator 2 are playing at the same frequency, but oscillator 1 is the only one that controls the output. So now I'm going to explain some of the parameters for oscillator 1. So first of all, SH1 is a sample and hold effect that can be applied to oscillator 1. The way this works is that the output of the oscillator is updated every n samples, where n is the value in SH1. If SH1 is 0, 1, the output is updated for every audio sample, and it sounds like a normal generator. However, if it's 2 or greater, the output is not always updated. If it is not updated, then the last calculated value is played back instead. This is the basic idea behind a sample and hold effect. Changing this value adds a nice bit of distortion to the oscillator. So I'm going to hold triangle and use the analog pad to raise this up. So depending upon the value you choose, that determines the type of distortion that you get in the generator. So I'm going to move this back to 0 so you can hear the waveform more clearly. Next, there's WT type 1. And this sets the waveform for oscillator 1. PSPSeq has 35 different waveforms that can be used in a number of places, including the BAM generator. These generally follow the form of sine waves, triangle waves, sawtooth waves, square waves, and noise waveforms. The way that PSPSeq provides so many different waveforms is that it performs some geometric operations on the basic waveforms. For example, it provides not just sine waves, but also sine squared waves and sine cubed waves, and to the 4th power waveforms as well. Plots of all the waveforms are in the user's guide under Appendix A. Changing WT type changes how the entire waveform sounds. So I've highlighted WT type 1, and I'm going to change this now by pushing up on the analog pad. So you can hear how Saw 4 sounds thinner than Saw. And now I've gone to SQ, which is a square wave. Noise is various noise waveforms. Tri is various triangle waves. And then these are some different sine waveforms. So you can see you have a lot of different options for what you want a waveform to sound like. So oscillator 2 has the exact same parameters for sample and hold and oscillator type as oscillator 1. So the waveforms for each oscillator are independent from each other. So you can see that SH2 and WT type 2 control the waveform types for oscillator 2. So now the os-sync parameter is used to sync the frequency of oscillator 2 to that of oscillator 1. So what I'm going to do is, first of all, I'm going to set osmix back to 0.5 by pushing square and then holding triangle and left trigger and pushing up and then down with the digital pad. And then what I'm going to do is change the I'm going to change the offset in this oscillator a little bit by holding triangle and then I'm going to set so that way the two oscillators are playing different frequencies. So now you can hear what it sounds like when the oscillators are not synced. And then if I sync the oscillators, you can hear that it sounds more like a single oscillator again, because they're both playing at the same frequency. So you can change the overall timbre of the sound by changing the offset between the two oscillators. So now I'm going to bring it down a little bit. Okay, so basically the idea of OsSync is that it forces the second oscillator to play at the same frequency as the first oscillator by resetting where it plays in the wavetable. So even if it's not finished with a complete cycle of a waveform, when the first oscillator finishes its cycle, the second oscillator is synced up again to play back at the beginning of the wavetable. So the next parameter is ring mix, and ring mix is used to modulate two oscillators. So ring modulation is simply a multiplication of the two waveforms, which adds additional harmonics. So I'm going to turn off OsSync right now, and then if I raise ring mix is basically the amount that the ring modulated waveform is mixed with the original waveform. So I'm going to bring this up. I'm just lowering the frequency so you can hear a little better. So, the sorts of sounds that you get out of ring modulating depends upon the, what your two waveforms are and what the offset between them is. So you can get a pretty wide range of sounds out of this. So the last four parameters I'm going to talk about in the BAM generator are common to a lot of the other audio generators in PSPSeq. I'll describe them in detail here, and then I'll gloss over them when I talk about the other generators in other tutorials. So first of all, the bottom two parameters are warp and warp wavetable. And they're used to add a random amount of low frequency oscillation to the frequency of the generator. A warp value of 0 means that the frequency is not warped at all, and 1.0 adds a maximum LFO amount. Both the rate and depth of the LFO are randomized with the warp. One thing to keep in mind with the warp is that PSPSeq loads a new warp amount on both trigger steps and control steps. Therefore, if you have a series of control steps like we have configured for the BAM generator, new random amounts of warp are loaded at every control step. Since you want to hear more clearly what warp sounds like, I'm going to go to a new loop that has just a single triggered note. So I'm going to exit the menu by pressing Start, and then I'm going to push right trigger to go to loop 2.